Before we end this chapter, let's talk a little bit about power. Power is the time rate of doing work. So what does that mean? Well, if we have power, which we write as P, it is the derivative of work with respect to time. Okay? So usually we write work as Newton meter. All right? So if work's Newton meter, we're talking a Newton meter per second. So a Newton meter per second, which is sometimes written as a joule per second. All right, and a joule per second is also a watt. So power is measured in watts, which we write as just a single capital W. And in the metric system, we use watts, but in the English system, we use something called horsepower, HP. And what is a horsepower? Well, we usually measure work in the English system as foot-pound. And so it's a foot-pound per second, but it's not that easy. All right, a horsepower is actually 550 foot-pounds per second. Okay, we need to make it confusing in the English system. So how do we calculate the power? Well, the power is equal to the force, and this is a vector, dotted with the velocity. All right, so these are both vectors here. So we can think of the force being this direction and the velocity being this direction. All right, so the power is the force dotted with the velocity. And remember, this is a scalar product, so power is a scalar, but this is also equal to the magnitude of F times the magnitude of V cosine angle theta, where theta is the angle between these two vectors. Okay. And the last thing I want to go over is the mechanical efficiency, which we write as this epsilon. So epsilon is the mechanical efficiency. Okay, and that is nothing more than the power output over the power input. All right, which is also can be equal to the energy output over the energy input. So the mechanical efficiency is always between 0 and 1. All right. We can never have the situation where we get more power out of a system than we put into it. All right, but it's a measure of how efficient the system is. So hopefully, if we've designed a well-made system, hopefully the efficiency is as close to 1 as we can get it.